Hey, welcome back. I am recording this one from my classroom, so I don't know if it feels different to you, but it sure feels different to me. So here we go. Well, this is the very last section in Chapter 1, Lesson 1.8. And we're going to take what we learned, the properties that we learned, and review the process of simplifying expressions. We have to identify like terms and combine them. And then we're also going to apply this process to word phrases. So here we go. All right, remember what simplifying means. It's the process of using addition and multiplication properties of real numbers, the ones that we learned in 1.7, to create a simpler expression. All right, so in example A, we can combine the 8 and the 9 together because they are like things, and we get 4x plus 9. All right. Now remember, we learned the distributive property, and in example B, we're going to multiply this 4 outside by each and every term on the inside. So we would get 12m plus 8n. On example C, why don't you guys try C and D on your own and see if you get it right. Come back and then watch me do it. Okay, welcome back. For C, I have to distribute this 3 across the parentheses. So I'm going to keep my 6, and then I have 12k plus 15. Don't forget to take that 3 times the 5 as well. All right, now I have a 15 and a 6. Those we're going to learn, those are like things, so I can add them together. So I get 12k plus 21. In example D, this is a -1. This is a sign. Remember, I call this the sign flipper. All right. So I have 5 minus 2y plus 8. Then I'm going to have a positive 5 and a positive 8. That gives me 13 minus 2y. And you're done. Okay? Now we're going to expand this to learn how to combine like variable terms. And we've seen this before, so this is still review. A term is a number or a variable or a product or quotient of numbers and variables. You can even have exponents. An example of a term would be 3. That is a term. We could also have 3x. That is a term. We could also have 3x cubed. That is a term. All right? So it is a number. We could have x, a variable, the product of a number or variable, 3 times x, and then variables raised to exponents. We could also have 3 divided by x, or x divided by 3. All right? The coefficient, when we use the word coefficient, we're talking about the number that is in front of a variable. So this example of 3, that would not be a coefficient, that would be a constant. But if we took 3x, 3 is the coefficient. Okay. If we said 2x squared, 2 is the coefficient. If we said 10 over x to the 4th, 10 is the coefficient. Okay. So it's the number right in front of the variable. It's important to be able to determine what's a term and what's a factor. All right? Terms are always, highlight this word, always, circle it, star it, whatever, separated by pluses or minuses, addition and subtraction. They're always separated, all right? So you have 3x plus 7x squared. 3x is a term and 7x squared is a term. We could have x squared plus 2x plus 4. X squared is a term, 2x is a term, 4 is a term, all right? Now factors are always two things, or at least two things, being multiplied. So if I looked at 3x, 3 is a factor and x is a factor, are factors. It's the parts that are being multiplied together. 7x squared, 7 and x are factors. We could also have binomials, x plus 2 and x minus 4. This is a factor, this is a factor. Like terms are terms that have the exact same variable with the exact same exponent. So, 3x and 2x, those are like terms because they're x to the first power. We can combine those. xy and 3xy. xy is a term, 3xy is a term. I can combine those to give me 4xy. Examples of unlike terms would be like 3x and 2y. xz and 3xyz. These would be different. This only has an xz as factors, but this has an xyz as factors. All right? So the like and unlike kind of depends on the variable. Now, constants are always likes. So we could have 3 and 8. And we can always combine those to equal 11. All right? Constants are like terms. When you're combining terms, terms must be like. And we're going to use the rules of signs to add the coefficients together to make a single term for each variable or variable with a power. Constants are always like terms. So I have a negative 9m plus 5m. Both of these are m terms, so I can combine them. So I have 9 negatives and 5 positive m's. So this would be negative 4m. In example B, I have 6r plus 3r plus 2r. All of my terms are r to the first power, so I can just add those coefficients together. I get 6 plus 3 plus 2, that's 11r. Why don't you try C, D, and E on your own and then come back. All right, welcome back. All right, I'm going to do C. I have a 4x plus a 1x. If there's no number there, it's understood to be 1. So you get 5x. On example D, I have 16y squared minus 9y squared. All right, these are both y squareds, so they're like things. Same letter, same power. 16 minus 9 is 7y squared. Now example E, I'm going to go up here so I don't get in my tools and start messing up the screen. I have a 32y plus 9y squared. Can I combine those? No, because this is not y squared. That's y to the first. This is y squared. These are not like, so you cannot combine them at all. All right, now it can get more complicated. You may have to distribute before you combine your like terms. So you want to make sure you do that. So I see a parenthesis and a number sitting out in front of it, so I'm going to use distribution. And I get 14 plus 12 plus 6y. Now I start looking for like things. 14 and 12 are both constants, so I can combine them. And I get 26 plus 6y. Example B, again, I have something that I have to distribute, so I'm going to take care of that first. 9k minus 6 minus negative 3 times 2 is negative 6. Negative 3 times negative 5 is a positive 15k. Now I'm going to combine my like things. I have a k term here and a k term here. They're both positive, so I'm going to add those coefficients together, and I get 24k. Now I have a negative 6 and a negative 6. So that gives me a total of negative 12. Why don't you try C? Now be careful, because that's a negative 1. That negative out in front is a sign flipper. So you put it on pause and try C on your own, and then come back and see if you got it right. All right, welcome back. I'm going to distribute first, and I get negative 2 plus r plus 10r. That gives me, I can combine these because they're like, so I get negative 2 plus 11r. All right. Now we have some more problems like this. Start on the inside if you want to. All right. So actually what I would do is I would multiply these two together and just get rid of that decimal. 100 times 0.03. I'm going to move my decimal 2 places, so that gives me 3 times x plus 4. So I get 3x plus 12. All right, why don't you try B on your own, and we'll come back and do C. All right, welcome back. On B, I'm going to distribute, and I get 10a minus 30 minus 12a plus 27. Do you see how this negative flips these signs in here? Now I'm going to combine like things. I have 10 positives and 12 negatives. So that leaves me negative 2a. Then I have 30 negatives and 27 positives. So that gives me negative 3. Okay. Now on C, here's what I'm going to do. I'm going to multiply and get rid of that fraction, fast and furious. I'm going to multiply by the common denominator, which is 6. So I'm going to multiply every term by 6 just to get rid of that fraction. Okay? So when I multiply 6 times negative 2/3, I get a negative 4 times x minus 6. Then when I multiply 6 times 1/6, I get a negative 1x. Now I'm going to distribute my 4, and I get negative 4x plus 24 minus 1x. You might have just wrote minus x. That's okay. I'm going to combine my likes, and I get negative 5x plus 24. All right. Again, if you aren't understanding something, go back and watch it again. All right, translating words into expressions, okay? The sum means we're going to add. The sum of 9, 5 times a number. 5 times a number says we're going to multiply, and I'm going to use x for my number. Then 4 times the same number. Notice how it says the number. It's referring to the same one. So that's 4 times x. And then 6 times the number. All right? So I had to add all of them up together. So I had 9 plus 5x plus 4x plus 6x. Now I'm going to look for like terms, and I can combine all my x terms, and that gives me 15 of them. So I have 9 plus 15x. You could also write it as 15x plus 9, and it would have the same meaning. Right? If you want to try B on your own, hit pause and come back and see if you got it right. All right, welcome back. 5 times a number added to the sum of the number and 3. 5 times a number. That says multiply by x. 5 times x. And then I have to add it to the sum. So I have 5x plus the sum of the number and 3. So I have 5x plus x plus 3. Now these parentheses aren't needed. If it was minus the sum of x plus 3, those parentheses would be needed. But I have 5x and 1x. That gives me 6x plus 30. Just like so. All right, what about going backwards and writing the expression into words? 9x minus, and then in parentheses, x plus 2. So this would be 9 times x minus the sum of, actually we should call this 9 times a number, minus the sum of the number plus 2. And I think this one I should have changed, this one I didn't, so we're not going to do that one. Okay? All right. A manufacturer has fixed costs of $1,000 to produce widgets. Each widget costs $5 to make. The manufacturer has fixed costs of $750 to produce gadgets. Each gadget costs $3 to make. Write an expression to describe the cost to make W widgets. Well, each widget costs $5 to make. So the cost is going to be $5 times every widget you make, which is equal to 5W. All right, now if we wanted to write an expression, actually, we have to add the fixed cost in there too. So it's 5 times every widget, plus he already has $1,000 before he makes one widget. Okay? Now, the manufacturer has fixed costs of $750 to produce gadgets, and then each gadget costs $3 to make. Okay? So the expression for the cost of gadgets is going to be $3 times every gadget plus the fixed cost that he has before he even produces one gadget. Right? Write an expression and simplify to make X widgets and Y gadgets. So all that means is just use the cost for the widget, use the variable X, and use the variable Y. I could have used X up here, 5X plus 100 and 1,000. 3y plus 750. Okay? So all I have to do is combine those two expressions together. So I get 5x plus 1,000 plus 3y plus 750, and then combine the like things. 5x plus 3y plus $1,750. All right? And here is our homework. Thanks for listening. I made it just before the bell rang. Woohoo! All right. I'll see you in about 2 hours. Bye.